So we're going to take a look at 3.3 properties of a function. You're going to have to learn what an even function is and an odd function is. So an even function is for every number x in its domain, that f of x equals f of negative x. So I'm going to show you how to go ahead and test for that. And even functions are symmetric with respect to the y-axis. So we've got a definition and then a visual. Odd functions. It's odd if for every number in x, its domain is f of negative x equals negative f of x. Odd functions are symmetric with respect to the origin. So you can have an even or an odd function. You do have to test for it. So the definitions right here are things that you need to memorize. If it asks if it's an even or an odd function, you're going to be testing those, and I'll show you how. So let's take a look at the first one here. It says determine whether the functions are even, odd, or neither. So you can be neither. So the first thing you're going to do is, if you're going to check if it's even, part of the definition says you have to plug in negative x. So up here it says you're going to plug in negative x into the function. So you have to show the plug-in step and then what it simplifies to. So negative x squared is actually a positive x squared. So you have a positive x squared next to the negative 3. So negative 3x squared, and the minus 7 stays. So that's the simplified version when you test the even. For the odd, well, actually, let me go back to the even. So you're going to be able to tell if something is even if your simplified answer matches the original. So if we take a look, when we simplified it, negative 3x squared minus 7 was the same as the original. And if you look here, that's what it says for the definition of an even. When you plug in negative x, it still equals the original function. So this is in fact even. Okay, so to test if it's odd, you have to first plug it into negative x, the definition says, which we already did. We have that. Now we need to plug it in with the negative sign in front of the f of x. So it's negative, and really, I'm going to write this down in 2 steps just to show you what I'm doing. So negative, and then I put the function here. So if you're taking the negative of the entire function, that means you're flipping all the signs around. That ends up being a positive 3x squared plus 7. So you're taking the negative of both of those terms, and then you're checking to see if something is odd. Does this equal this? Because again, that's what the definition says when you go back up here. Does f of negative x equal negative f of x? If so, it is odd. Those two equations are not the same, so no, it is not odd. Neither would be if they're obviously both no. So this is an even function, okay? This is an even function. So let's go ahead and test for the next one. So we're going to go ahead and test if it's even by plugging in negative x. So I'm going to say 2 times negative x cubed minus negative x. And then I'm going to simplify that. Negative x cubed is still a negative. So it's going to be a negative 2x cubed. You need to simplify it. The negative sign should be by the 2, not by the x any longer. Negative times a negative x is a plus x. So that's the simplified answer. And again, for an even function, you're checking. Does this function, when I plugged in negative x, equal the original? The answer is no. So then we're going to go ahead and plug in and check for the odd. So for the odd, you have to first find the negative x, which we already did, and now you have to find the negative of the entire function. And again, the negative of the entire function just means you're flipping the signs to everything. So I'm just going to go ahead and do that in 1 step here. And then to see if it's odd, you're checking if negative g of x equals g of negative x. And if so, then it is odd. In this case, it is. So this is a odd function. Again, why is this one odd? Because g of negative x is equal to negative g of x. That's how you know it's odd. And the last one, and if I go ahead and kind of clean this up a little bit, I can write this one is even. And if you're asked why is it even, it's because of the definition f of x is equal to f of negative x. That's why. All right, let's go ahead and try the next problem. So there's our function. We're first going to go ahead and check to see if it's even by plugging in negative x. So when we plug in negative x, that's going to end up giving us still a negative sign. You pull the negative in the front, negative 3x cubed plus 5. That's my simplified answer. Again, you're checking. Does this negative x when I plugged it in equal the original? It does not, so it's not even. So I'm going to go on and check negative h of x, which just flips all the signs. And for this one, remember, you're not checking back with the original one. You're checking, does negative h of x equal h of negative x? So you're going back to check this one. And the answer is no, because one's a minus 5 and one's a plus 5. So this one happens to be neither. Again, you have to show plugging in both of those things to draw your conclusion. You have to plug in negative x and you have to do negative f of x, okay? Every time I should see that for you to draw your conclusion if it's even, odd, or neither. And again, this one's neither because none of those are true, none of those statements, which I guess I could have written right here, but I missed that. Okay, there we go. So you do need to know those. So what I highlighted in green and red, please memorize those definitions. Next thing is increasing, decreasing, and constant functions. This is stuff that really you do know because it's just like slope. So if we have an increasing function for a certain interval, then the graph is moving up from left to right. So like a slope, it is increasing. If it is a decreasing function over a given interval, then it's moving down from left to right. So it's going downwards. That's a negative slope. A constant function is a function between an interval when the graph is horizontal. So part of the graph will look like this. So you can have a graph that has increasing parts, decreasing parts, and constant parts. So just as a really important note, it says when asked for intervals, intervals are always x values. I don't know how to stress that enough, but intervals are always, always, always x values. And a lot of students will get that wrong because they'll name y values. You got to memorize that now. And it's the same, you know, it's going to be the same all year. Whenever we ask for an interval, we're talking about the x values, okay? So if we're taking a look at this example to determine the intervals, so again, the intervals, so they're x values, that's what that's saying, over which the function is increasing, decreasing, or constant. And then it tells us the 2 points at the bend. So it says in this example here that this is 0, 0, and the other bend here is 5, 25. And this is a picture from a graph, and we will be using your graphing calculator. So from left to right, notice that this part of the graph is going down, which means it's decreasing. So the function is decreasing. And I'm going to add arrows onto this graph because this is from a calculator and your calculator is not going to have arrows on it. It only shows the portion that you're looking at. So this is decreasing from left to right from, and again, you're naming your x values. This is negative infinity on your x values. This is positive infinity on your x values. So it's decreasing from negative infinity up until, notice where my pink line stopped. It stopped at 0. And I'm going to use a parenthesis because at 0, it's, it's constant. It's technically decreasing and increasing at 0. So we use a parenthesis. It's not just one thing. And then a function is increasing. If we take a look at the next portion, which I'm going to do in purple, notice from 0 on, this little part here in purple, it's going up from left to right. So the interval, the x values, again, you drop down to kind of see where the x values are, is from 0 is where the purple started to 5 is the next x value. And then constant is a horizontal line. So if we look for the constant, which I'm going to go ahead and do in gray, it started at 5 for the x value, and it's going towards infinity. So it's 5 to infinity. So you're looking left to right for your intervals. So you're going to be doing a lot of that all year long with lots of different types of graphs. You're also going to be talking about max and minimums a lot. And max and minimums are going to be just like they sound. So for a maximum, it's going to be over an interval, and it's going to be, let me draw a little picture here. Kind of like when you have an upside down U, it's going to be the top point of it. That is a maximum, okay? And then the local minimum is going to be over a certain interval, and that would look something like this, where there is a minimum value to it. There's a bottom to it. It doesn't go below it. And then absolute maximum and absolute minimum. The difference between these is a local one, you can have many of these, and I'll show you graphs where there literally are many maximums and minimums. But for the absolute maximum, the absolute minimum, you're looking at the entire graph. Which one is the lowest point? Which one is the highest point? So for instance, a absolute maximum would be the highest of the entire thing. So even though you have two local maximums here, there is only one absolute maximum, which is the highest of the entire thing. Same thing if I draw a graph like this. There's two local minimums, but there is only one absolute minimum because you're finding the lowest point on the entire thing. So this would only be 1 point. So the extreme value theorem is if f is continuous function whose domain is closed in the interval, then it has an absolute maximum and absolute minimum for a certain closed interval. And we'll talk about what that looks like, how you're going to be using the extreme value theorem. So you're going to be looking at lots of graphs. So here it says f has a local maximum at blank. So we're looking at a local maximum. So if you follow this graph, where is there kind of like that upside down U? And we have one located right here. That's going to be your local maximum, okay? So if we take a look at that, we're going to say it has a local maximum at -1 because it's going to be at the x value. So the value is f of x equals, remember this just means y, so y equals 7 when that x is -1. It also has a local minimum. If we take a look, there's two local, because remember you can have multiple for the locals. There's one here and one here. You're looking for the u's, right? So we have a local minimum at, you're going to name the x values here, -5 and 2. So again, I just took the x values here. And the local values are at, remember f of x just means y. So those actual values are at when y is 1 and y is -6, which again, I just pulled. Well, let's not make it look like that, but I pulled from right here. So again, these two are what we call your minimums. If I asked you for the absolute, I know it doesn't, but I just want to make sure you understand. If I ask for the absolute minimum, it would just be this value because it would be the lowest point out of everything, okay? Same with the highest one, there is only 1 point, so you really can't confuse the two. Take a look at the next one. It says the function has a domain. So these n, there are not arrows there. So the domain is from your left to the right side. It's always smallest to largest. So if I'm taking a look here, I'm looking from this x to this x. And they're very helpful and they list the points here so you don't have to count. So it has a domain of -8, and I'm going to include it because it ends there. It's not doing something else at the end. There's not an arrow. So -8 to 2. and it says the largest value of f is f of blank. So the largest value, you're looking for a maximum. Largest value, you're looking for a maximum. So there is, the highest point here is going to be located right here. Notice that that's the absolute max. Technically, it's also a local max because there's only one maximum. So that's the absolute max. And it's located at f of -6, because inside that parentheses is the x, and it equals 4. And we would call that the absolute max. Whenever it's a largest value, it's going to be the absolute max. The smallest value, we're looking for the minimum. Where is the low point? And that's going to be located right here. This is going to be our absolute minimum. And we can say f of -3 is equal to -8, and that's our absolute minimum. So you'll be practicing a bunch of those. So maximum high, minimum low. You're going to be doing this on the calculator. So if you don't have one, go get one now. There is multiple steps to this. I will do another example in class, but you will be doing this on your calculator over and over. It's not just this unit. So you need to make sure that you can do this problem. Here are the steps, but I am going to walk you through the steps as well, okay? So we're going to do them with example 6 because it's easiest to understand the steps when you're actually doing them. So again, you're going to want to grab a calculator here so that you can follow what I'm doing, okay? So it says type in to find the turning points here. So we're going to go ahead and type in this equation, okay? So you're going to type x. X is this button right here. You see the X, you're going to do X to the, you're going to use this arrow here, X to the 4th. I got to find my 4. And then I'm going to arrow out and I'm going to type the rest of it in. So X to the 4th minus 5x cubed plus 3x minus 8. So pause me if you need to type that in. You want to practice that. So I've got it completely typed in. And we're going to find some turning points, minimums, maximums, where it's increasing and where it's decreasing, okay? So first thing I'm going to do, I'm going to press graph, and I'm going to see what shows up. I don't know what my settings are on right now. Notice I can't see my entire graph at all. See, the bottom part is missing here. So I am going to go to very close to seeing the whole thing. So I'm going to have to go ahead and change the window. So if you take a look at my graph, and maybe yours looks like mine, but I don't have the whole graph. I don't have the bottom of it, okay? So I'm going to go ahead and press window right here, and I don't have the bottom. If I don't have the bottom, that's my Y values. So notice my Y min right now is -10, and that's not enough. I need a lower Y min. So I'm going to go ahead and try, I don't know, -25. Maybe that works, maybe it doesn't. So I typed in -25 under the Y min, and then I'm going to click graph. Notice on my graph, it's still not low enough. I still don't see the bottom of that point, and I need that point, okay? I need that minimum. So I'm going to press window again, and I'm going to change my Y min, not -25. I'm going to try maybe -50. -50. And I'm going to hit graph. And I'm going to see, okay, can I see the bottom of my graph now? Oh, no, I'm getting a lot closer, though. So maybe -75 will work. So again, I'm going to go to window right here. I'm going to go to the Y min. Now I'm going to try -75. I'm thinking this is going to work because I was really close before. Yay, I can see the bottoms of my graph, okay? And I need those because I need to find the turning points. Turning points are pretty much just where are your turning points are when it goes from an increasing to a decreasing function or decreasing to increasing. So those are your minimum and maximum values. So that's the first thing that it asks for. So I'm going to draw a rough sketch of what this picture looks like so I can keep talking about it. So this graph that my calculator has looks like this. Okay, it's something like that. And the turning points are again where it goes from an increasing to a decreasing function or decreasing to increasing. So there are your max and min values here, okay? So those are your turning points. There are 3 of them, right? There are 3 turning points here. We need to find them. So this is how you're going to go ahead and find them. And again, the directions are here, but it's going to be a series of pressing the trace button, the second trace button. There's going to be a calculator option in there, and you're going to have to decide if you're doing a min or a max. And then you're going to do a combine of these left bound, right bound, and guess. Again, I'm going to walk you through these steps because it's easier to understand when you do them. So we should all be staring at this screen. You're going to go ahead and press second trace, and we're going to find, let's find the lowest minimum. It's up to you. But do you see how option 3 is a minimum? I'm going to hit enter. And there's 2 minimums located here, right? I'm going to go to this one all the way down there. I want to find that one. The first thing it says is left bound. You can move your arrows left and right, okay? And you see how that cursor moves with it? I want to be left bound of that point. So if my point is right here, I don't know what it's at, but I want to be to the left of it. Any point to the left of that point. That is to the left of it. And I'm going to hit enter. I also want to then, it says right bound. I want to go to the right of that point. So notice how I moved my arrow. I was pressing the right button. If that's the point there that I'm trying to find, I'm going to the right of it. I'm telling my calculator that this point is between that left point and the right point. And then it says guess. Guess just means take your cursor. I got to go back to the left and get kind of close to the minimum. So now my cursor is kind of close to it. I'm going to hit enter. And it calculates the exact value for me. I see people who try to guess it by using the calculator. You do not get the exact numbers. You can only do this through a calculator. So the value there is located at 3.70. Oops, let me get out of there. 3.70 is the X, and then the Y says negative 62.75. I'm rounding to the nearest hundredth, so 2 decimals. That's the point there. Again, your calculator has to do it for you. I did not know what that was. That's going to be one of our turning points. Let's find the other minimum. So you notice there's a minimum here and a minimum here. So now we're going to calculate the other one by following the same steps. So again, I'm going to go to second trace because that says calc. We want to calculate something. I'm going to arrow down to the minimum, hit enter. Now this point's all the way up here, so I need to be to the left of it. So my cursor, I have to move it to the left of that minimum. So I'm moving. Okay, there. Now it's blinking to the left of it. I hit enter. Now it says right bound. Now I need to move it to the right of my minimum. That's to the right of it, and I hit enter. Now it says guess, so I'm just going to get somewhere close to the bottom of the minimum. That's somewhere close. And I hit enter. And it says my minimum is located at negative 0.42. Again, I'm rounding to the nearest hundredth, comma negative 8.86. Again, I'm reading those numbers directly from the bottom of the screen, okay? All right, so we've got 2 out of 3 done. Notice now we have a maximum. There's only one thing different when you're looking for your maximum. The steps so far are the same. When you go to second trace, if we want to find a maximum, you need to pick the maximum option here. So that's option 4. And I hit enter, but everything else is the same. If this is my maximum up here, I want to do something to the left of it. So I can actually go ahead and just hit enter right now. Now I want to go to the right of that. So somewhere over here, and there's lots of enters you could press. You don't have to have your spot in the exact spot as mine. And then my guess, I don't know, somewhere near the top, I hit enter. Then my calculator does it for me. And my minimum, or I'm sorry, my maximum is at 0.48. Oops. And the y value is negative 7.06. Again, you can't calculate those. Your calculator has to do that. So the turning points, there are 3 of them. And I always like to draw a picture and list them. So the turning points, I just am going to copy it down here. So I've got 0.48, comma, negative 7.06. That's one. Oops. I have another one that is negative 0.42, comma, negative 8.86. And then I've got 3.70, and that's negative 62.75. Again, your turning points are just your max and mins, okay? But you have to use your calculator to find them. The minimums, we have 3 minimums here, right? I'm sorry, 2 minimums here. We have a minimum, a low point here, and we have a low point here. So when they're asking for the actual minima, we're going to go ahead and I'm going to write this in Y. Your minimum is going to be your Y values, okay? So this is going to be your Y values when they ask for the minima or the maxima. You're going to list your Y values. So the minimum here, the Y values, and the Y values for those points are negative 8.86 and negative 62.75. So negative 8.86. And because there's 2 of them, negative 62.75. The maximums, we'll go ahead and do those in green. The maximum, this is our maximum right here. And our maximum, again, we're going to do the Y value. So you're going to list that as negative 7.06. And there's only one of those. There's not another maximum there. The next question says increasing or decreasing. So this is where you're looking at the slope. Where is it increasing? Where is it decreasing? That's why the turning points are important. The turning points are important because they're going to tell you when it goes from an increasing to a decreasing or a constant. So when you do increasing and decreasing, you're always going to label these in X's, okay? So I'm going to go ahead and switch to purple now. So intervals, again, are always X's. So when is this function increasing? So from left to right, when is it going up? There's 2 spots where it's going up here, okay? And that's going to be here and here. Both parts of those graphs is going up from left to right. So now we have to list those in X terms. So from negative 0.42 to 0.48. That's one interval from the X's. From negative 0.42 it starts and it goes until positive 0.48. Union, because there's another interval, and that goes from 3.70 until infinity because of the arrow. It keeps going to the right. We also have to look at the decreasing portion. So if we take a look at the decreasing portion, from left to right, this is going down. There's 2 parts that are going to be decreasing. So when I go ahead and I write those again, you're doing the X's. So it's from negative infinity up until this negative 0.42. Union, the next spot that I did in gray is the negative 0.4, sorry, it's not negative, it's positive. Positive 0.48 up until, if I follow that line down, is until 3.70. Again, when it says increasing or decreasing, you're naming X's. If it asks for the minimum or the maxima, you're naming Y's. You write that down because that's the number one errors. I see people naming Y's and X's in the wrong spots, and that will be completely wrong. All right, the last type of problem that you're going to see is the average rate of change, which is just very much like a slope problem here. So we already know what the average rate of change is. It's the change in Y over the change in X. So what that means is you're pretty much calculating slope, but in function notation. Because remember, f of b just means y. This is just saying y2 minus y1. So you're just subtracting the y's over. The bottom part is pretty much just saying x2 minus x1. They're just using a's and b's and f's. So find the average rate of change from 2 to 5. So again, these are your x values. So let's go ahead and plug in 2 for x so we can find out what the y is. So -4 times 2 minus 1. When you plug that in, you get -9. So that becomes the point 2, -9. Now let's go ahead and find when x is 5. When I plug in 5 for x, I get -4 times 5 minus 1. And that's going to get me -21. So that's the point 5 comma -21. So my suggestion for you is create 2 points because you all know how to calculate slope given 2 points. So plug the x values in to find y and then do your slope formula. y2 minus y1 all over x2 minus x1. So on the top, we're going to get a plus plus, so that's going to get me a -12 over 3. And when that simplifies, that's going to get me a -4. So that is my final answer there. That's my slope, which we should know that because this was just a linear function. Notice -4 was the slope. That's not going to happen every time because if you look in other problems, they're not always going to be linear. But that was just one that you should be able to notice. You're going to be finding slopes of the secant line. So the slopes of the secant line, it doesn't even really matter if you understand what the word secant means. What matters is that you can find the slope of it. So it's just using the slope formula. So here, once again, they're finding what points. We need to have 2 points. We don't know those points. We know it's -1 comma something, and we know it's 2 comma something. So to find the y's, you plug them in for x. So that should not be hard. You're going to go ahead and plug in -1 for x to find the y. So that's going to give me a -1, which means I have the point -1, -1. Then I'm going to plug in the other point, which is a +2. So I've got 2 squared minus 2, which gets me a 2. So my other point is going to be 2 comma 2. And now I'm going to find the slope. You can't just tell what the slope is of this problem because it's not a linear equation. So here are my 2 points. You calculate slope by doing y2 minus y1. So 2 minus -1 equals x2 minus x1. And what you're going to end up getting is 3 over 3. So your slope is 1 in this problem. If they tell you 2 other points, you can get a totally different answer, okay? Because this is a U-shaped problem. So depending on what points they ask, your slope is going to change. The secant line is the line that is going to look like this. So depending on where you do it, the slope looks totally different, right? So it depends what those x values are that they give you. So part B says use the answer from part A to find the equation of the secant line. So I'm going to have you do this problem after I start it. So we just found that the slope is 1, and we found any of the points, pick them. I'm going to pick the point 2 comma 2. You should be able to write the equation of our line based off of our last unit. So I'm going to go ahead and say stop and write the equation of the line in slope-intercept form, please. Slope-intercept form. Okay. So welcome back. Let's go ahead and give this a try. In slope-intercept form, I would start with point slope. I would plug it into y minus 2. The slope is 1, x minus 2. So I plugged it into point slope. I'm going to distribute the 1. That gives me x minus 2. And then I'm going to go ahead and solve for y to get it into slope-intercept form. And -2 plus 2 is 0. So I have only the equation y equals x. That is, in slope-intercept form, the equation. All right, guys, thank you for listening. We will do another calculator problem together because I'm going to guess that we need some more practice, and be ready to ask questions if you don't get something.